Let me show you the battery bank that I have. So what it is it's these are AGM batteries, universal batteries. Most of these, the brands of these. It's a 12350 model battery, and they ran me between $65 and $75 each, and that's not including shipping. So we're depending upon where you are. If you order these online, you might have to pay a lot for shipping. I think these are manufactured in China, and the distributor I got them was Batteries ASAP on the internet. And those two copper bars, I'm just using those in place of the of cables. So I know a lot of people say, well, that's not the proper way to do it. You use cables and you do it all according to the uniform building code and electrical compliance. So you must have the battery cable to cable between batteries as a rule, and I'm just not following that rule. I thought, you know what, I'll just buy these rods and I'll thread them through these batteries, and that'll just be easier than just making a whole bunch of cables and tying all the batteries together with the cables. And here's the end for the negative, and you can see this battery here is on here, and this thing here is that green wire. Green wire goes to that copper plate up there on the negative side that all my charge controllers are tied to, and then this is the positive side to my inverter. So underneath that inverter there, I have this red wire going to the positive side of the input on the inverter. Sorry about shaky hand. And then so that's the negative side to the plates where all of the charge controllers are attached to. What I did is I reamed those posts. How I got that copper threaded bar, I think that's 3/8. What I did is I used a reamer, and I reamed out the lead so that the bar would slide through there somewhat snugly, and tried to do it as snug as I could. I tapped it with a rubber mallet so I could get this long bar through all of them. I'm just doing one at a time. And then the other end here, this is a Harbor Freight power strip I put in to my inverter, and the other end has the positive side to the charge controllers. That green wire right there goes to the positive plate that's up above my workbench that you see, and then that end right there is going to this negative here on this inverter. And this is the PowerBright 1500 watt sine inverter that I have. That's worked pretty well. And so those are the batteries, and I bought them at different times. So I bought them like, you know, a year. One year I bought 3, 1 year I bought 2, 1 year I bought 3 again, and so like that I've been adding to it. I'm going to show you the load. I'm going to put a load on it so you can see the results. See the in process of the power, how the power consumes the power coming out from the batteries, and how the power gets delivered to the batteries for charging the batteries. So I'll do both of those at the same time. I'll show you this being how much power I'm using from AC, which is coming off of that inverter that changes the DC power into AC power. And now I have this 1000 watt popcorn maker connected. Now the sun's coming out, so I might be able to do a demo. And then this is the amp meter, and I think I got this on either Blue Seas, or I got it on might be Blue Seas brand, but I either got that on Amazon or I got it on electrical supply website. And this goes up to 100 amps, and that's that green wire is tied to that. There's a bridge. I'm sorry. This is jumping across the negative side to the batteries. So that's what that is down there. That's all of the power coming from all my charge controllers are routed through across that bridge, and the amp meter is measuring the flow of the amperes of the power flowing through this wire. It's going to that bridge, and then that other side of the bridge, it goes to the corner of the battery bank on the negative end down there, on that side down there. So this is measuring the flow of the power across the bridge, and that bridge right there, that came with the amp meter when I bought it. I didn't have to buy that separate, and I just put one side to the, it's all negative. Those two lines are going to one end negative and the other end's negative, so these are both negative, these wires here, and they're measuring the power flow. And now the sun's coming out, I can show you my regulators coming on. They're off right now. See, it's detecting it's fully charged. That's saying it's fully charged. That's thinking it's fully charged too. And that's thinking it's fully charged. And this regulator, this regulator, this regulator, and this regulator are going to those panels up there. See them? I don't know if you can see them or not. Let's point the camera. And these ones over here. So those regulators are going. Those three panels up there you see, those kyoceras, the 120 watt kyoceras that were used. I got them on eBay. Those three and the other two on the other side. Those two that I showed you up there, those are going to, so this regulator, each individually, this regulator, and this regulator. Now one of the panels is directly tied to this, to those two plates, because I'm not using a regulator, but I do have that fountain on all the time, and it kind of takes I don't overcharge the batteries. And I'll show you, that's the voltage on the plates, that plate negative and that plate negative. That's measuring the voltage, and that voltmeter here is measuring the negative and positive side of the battery bank down here. So anyhow, I'll show you it. Turn this on. See the level of the power coming in from the sun to charge the batteries. These are the amps I'm getting. And as the sun is blocked by clouds, and then it comes out again, and then the regulators let more power through, that needle will go higher. See, it's on a red light now, it means it's letting power through. It's low voltage, it's letting power in. I'm getting that many amps, which is 14 to 17 volts coming in. And then this will jump. That's the voltage from the two 24 volt panels, and it's changing because it's allowing the power through here to get through here. It's measuring actually the voltage from my batteries. If I turn the panels off, that'll just show battery voltage. So that's right now, that's battery voltage. That's what my batteries are. Same as that. Now if I turn this on, it says, oh, the sun's out, time to turn on, let power in. And that's the voltage of the two panels on the roof. The 24 volt panels, that's the voltage of them right now. And you'll see that'll drop, and it'll allow the power to come through here, and it'll start letting power through to the battery bank. This is about 1,000 watts, so that's how many amps. That's how many amps that popcorn maker's drawing right now. 115 volts. That's how much it's costing me. That's how many volts this is. Yeah. That's how many watts I'm drawing from here. But I'm gonna have to turn it off because it's under voltage now. So that alarm goes off. I'm not getting enough power in. So it's drawing more power from the batteries than I'm getting from solar, so I'll just turn it off here. Anyhow, that's system status right now. See you around. Bye.